Test. Hello. Yeah, okay, I think we can get started. Yeah, my name is Tim, and I'm going to talk about building a web-ready synthesizer for the web in WASM and using C++. There's a bit of a demo here already. And a bit about myself. So I'm actually a crypto dev in exile, I would say. I also play piano since 3 years, and I've been using Ableton Live since a while, just to experiment. And in my free time, I do hacking, which means I'm part of a group that's called Social Distortion Protocol. There's a bunch of people here too. And we go mainly to Chaos Computer Club events like the camp, where we had our own dome, and now we even have a flag. And so I like to explore stuff and just try new things that interest me. Just a quick demo to get you to get you hooked on the talk, maybe. So it's a website. It's WASM Synth. That's the project, and basically what I can do now is I can just use my fingers to generate audio using this software keyboard, and it's very much, I've taken inspiration from the Ableton Live operator instrument, so I can of course, these are my 4 oscillators that I have. I can turn some of them off, I can change the waveform, and now I get a different sound. There's also this attack, decay, sustain, and release graph that I've made, and so what I can also do is I can just increase the period of the release of the sound, basically. So when I press a key now, you can hear it sustain. And of course, everything that you can touch in this interface, so the buttons here, the graph itself, and all of that, it's all responsive in real time. So when I press a button and I change, as you've heard, then the sound changes too. So it's similar to, I think, how Paul's demo worked before. So, and in the talk, I essentially want to go over the journey that I made to get to that project, basically, right? So yeah, I don't know, I came to Berlin, I think in 2015, and I started to work at a company that was doing cryptocurrency stuff. And after, I don't know, it's like now 5 years or something, and it got a bit boring. And then in the meantime, I also started to learn playing the piano, and what was really interesting was the music theory behind it, and I really, thanks to my teacher, started to understand way more. But what I really didn't understand was these audio tools and all of the different labels and things they used, and so I was a bit confused, and I played around a bit, but for a really long time I didn't fully understand what it was all about and how I could reference that back to music theory that I learned in just regular piano lessons. And so, since the background is also that I'm a hacker in a sense, and I'm aware of the hacker ethic, it says that all information should be free and that you can create art and beauty on a computer, and simply also for the reason that I'm a hacker and I like to do my own things, I said, okay, the one thing that I learned, especially from these chaos events, is that when you start to reverse engineer something, it's a really great way of learning that concept or that tool, or just like learning something autodidactically. And so basically I said, okay, let's go, I want to build the synthesizer myself. So how that looked like, I drew a very great Gantt chart here from my, it's very detailed. So for me, the goals were really just to build something for the web that I really liked, to learn a new programming language that turned out to be C++ and WebAssembly essentially, And then another goal was to avoid any third-party libraries. So I didn't want to include just one heavy, I don't know, C++ library that allowed me to create all sorts of like audio things. I just wanted to do it all by scratch to really learn also the math and everything that's behind it. And overall, the goal was to learn audio programming. And so here's a quick overview over the architecture of the project. In the front end, I'm using React.js, so just because I'm very familiar with it, and I've been using it since a while. And then I think you have already seen the message part of the audio worklet. I'm communicating with the audio worklet through a messaging port, and then I wrote my own adapter that I can use to control the WASM code that I have written. And in the lower part of the picture, you can see that there's also some WASM code that I'm using. And so in this presentation, I think it would explode the scope if I wanted to talk about all of the things that I had to do, but I want to focus particularly on 3 problems that I had when working with the combination of like React, the audio worklet, and WebAssembly. And the problems happened here, so kind of like in this section, where I'm trying to share code, like where I'm trying to share data basically between WASM and JavaScript or the audio worklet, then in the audio worklet itself, and then in the communication port itself. So I'm going to go into each of these and talk a bit about it. So sharing data between threads, I think we've seen a superior approach than what I'm going to show now, because I'm basically using the messaging port. So yeah, just to repeat a bit, you have this main thread on your browser where all the JavaScript is running essentially. So that's where React.js is. And then on the other side, of course, you have this worklet thread that gets instantiated once in the main thread you load the worklet. So it's like spawned off somehow. And that means, it's global scope, and in general, the scopes of these 2 threads differ, meaning you cannot just simply, for example, call a function from here, or access data or something like that. So you have to go through the message port, right? How does that work? Yeah, we've seen it already. Just very briefly, on the left you can see the audio worklet, and you can see the port property being accessed and advanced with the onMessage function that I wrote myself. So it's just basically returning a POM. And then on the other side, in your main thread, basically, it's a bit convoluted because it didn't really fit on the slide, but yeah, you initialize the audio context by creating an audio context. You add the audio worklet, and then what you can do is you can just use the port. I don't know. I don't think that code will run. But essentially what you do is on the worklet itself, you call the port property, and then you post the message, and then that message comes here, and then you do a pong, and basically the message comes back here, right? So it's essentially a bidirectional communication port, and for me, it's just, I know Node.js, and when you spawn threads there, it's very similar. You have like this, it's extremely similar. So then I think the second problem that maybe you might, you probably you're not aware of yet, and I think there was even a question about it, was like, how do I share data between WebAssembly and JavaScript? And I think if we look at the architecture from a higher level, basically, then we have in the browser the JavaScript sandbox. It's running some JavaScript, and of course it's, as you've seen before, it's threaded, right? But then, of course, we also have WASM, which runs somewhere different. And now the question is, how can we share data between kind of these 2 sandboxes or things? And I think the most low-level interface for that I found was this, what they call linear memory. Essentially, you can see you can see an example of how to use it here. It is sandboxed, meaning that it's not, the memory is neither embedded into the memory of JavaScript, nor is it embedded into the WASM. So just to make an example, just because I write something into this linear memory doesn't mean that I'm altering the memory of WASM itself, right? I think that might be a bit dangerous. So it's sandboxed, and it's essentially an untyped byte array. And then essentially what we can see, this is a JavaScript file, so we are initializing the memory with pages. So each page basically is 64 kilobytes worth of data that we can put. So we are initializing 640 kilobytes with a maximum of 6.4 megabytes. And then once we pass it to this unsigned integer, what we can simply do is we can put data into it, right? And we can of course read from that data again. And on the other side, of course, we can do the same, and that's how we establish a connection essentially. Now, as I said, it's untyped, so I think working with more complex data structures, that becomes quite difficult, I think, after a while, or annoying. So you might want to use something that eases kind of this data sharing. And for C++, essentially, there is this great tool called mbind. Mbind is essentially shipped with mscripten. So just a quick intro, mscripten is a compiler that takes your C++ files and moves them into WASM and generates some glue code, and then you can simply run that in a browser. And many like examples you've seen from Reddit or Hacker News or something, they are usually using when someone builds like a really cool game and you can run it in the browser, or a Windows VM, I think there was like Windows 95 VM or something. That's usually done with mscripten. And here's a quick example of how that works, mscripten and mbind. So you have your C++ file on the left, and you can see that we have this function called hello, and it's just returning a hello world string. And then the speciality of this is that we're using the mscripten namespace essentially, and we are binding that function to this my module essentially. And what we then get when we compile the C++ file is we get this as an output, this main.js file, and the minus bind is helping us to generate that stuff. And then what we can do essentially is we can just use this in our HTML. So we can basically the main.js is glue code, as I said, constructed by mscripten. It loads a bunch of stuff. There is like all of this linear memory is basically abstracted from you away, and you can just use the module object. You call the onRuntime initialize function, which basically tells you when the WebAssembly is ready to run, and then you use any kind of C++ functions or even classes, just like regular JavaScript classes. So here you can see that I'm just using the module.hello, and my output is going to be hello world. So that's, in my opinion, that's already super cool, and I think this was actually also the first code that I wrote. To me that was super useful. There is a bit of lack of tooling for mscripten in general. Of course, there is mscripten, but then I think if you're a web developer, then you're expecting also like a bundler to work with mscripten, so something like a Webpack or Rollup or something like that. And unfortunately, that doesn't exist yet, or at least not in the capability that it's like super useful or really quick to set up. What is cool about this approach though, like using WASM and also like building for, like in my case, for example, I've built all of my audio software basically in C++ and compiled to WASM. and then all of the UI is made in JavaScript, is I can port this code, of course, anywhere, right? I can, the C++ code that I wrote is just C++ code. I can technically compile it to any kind of like operating system. I can use it, I can still leave it in WebAssembly, and I don't know, run it wherever WebAssembly runs, so that's really cool. And then of course you have this promise of a performance boost, which I don't think I'm the right person to say anything about it. I have Googled a bunch around, and to me it's difficult to say like, yes, it's a performance boost or no. But I think we've seen a demo that already shows that it's quite cool what you can do. I think one of the takeaways that I got from one conference where a Google person was speaking was that, since you can use something like a typed language where you really know in what routines you're falling into, you can of course optimize performance and reliance on this performance. Then the third problem that I wanted to tackle was, of course, this real-time audio generation. So it's basically within this or process function that gets called in the audio workload. And so I just wanted to show that again very briefly. It's essentially that I can press a button and I can change a parameter on the synth itself, and of course it will update and it will not, I don't know, only do that once I press a new button or something like that, but it's responsive in real time. So I don't know, maybe this is obvious for people that work a lot with audio. It wasn't for me. I've never worked with it. So essentially how this all works is you are generating a bunch of samples, and since we are in the digital space, we can only approximate the signal that, I don't know, a guitar makes in the physical space. So we are basically producing a bunch of floats, for example, in an array, and then we're sending that off to a sound card, and then the sound card takes care of, sending it to the wire, and somehow the membrane is getting shook. And if we do that, if that array that we have here, in this example is, for example, 1 second worth of audio. So say we have 48 kilohertz sampling rate, and we have 48,000 samples here. Then of course, when the user presses a button, they technically would have to press that button each time we are starting to render a new sample, because if the user wouldn't do that, of course, latency would occur and the user would notice that latency, and so, for example, they would press a button, but nothing would really change, right? And so that's kind of the concept of frames, and really it goes, I think, beyond that in terms of concepts, because I think simply what we can call it is streaming, and streaming data. So, I mean, usually that's attributed to services, so we can stream music or video, but for me at least, it wasn't really clear how that worked on a data structure level. And so we had the talk before about the ring buffer. I think a really good example of how that works and how we can actually implement data streaming on a computer is by using a ring buffer essentially. And in this picture, what you can see essentially, there is an array with a limited size that we can set ourselves essentially. And in this case, the array is reading the input of the keyboard, and then there's a processor, which is, I think, the blue pointer that is basically, I don't know, taking that input and putting it into, let's say, a text editor or something. Okay, so I type, and then text shows up, right? That's kind of like the streaming, essentially. And what we can see here is that, of course, then we can make this continuous, right, by typing fast enough such that the the read pointer always has to chase the write pointer. And I think very similar in audio, that's at least how I explained it to myself, is that, you know, we can configure the write pointer to a, you know, a rate of reading that is similar to the sampling rate, and so then it kind of dictates the speed of the write pointer essentially. Yeah, I think audio workload is really helpful for doing that. And yeah, just as like a brief example of how it works, I think we saw it before, is you write your own class and you extend it with this audio workload processor. Then in my case, I also inserted the WASM code. So I have this globally defined module, this one here. So I just instantiated now, my WASM code is loaded, and now once the processing starts and you know, I need to generate audio, in this case I'm also just generating noise. Basically, you know, I will be called through process each time, and I can just I can offload that to my WASM module, essentially generate the noise, and with mbind send it back to the output channel, and then we have audio as we've seen before in the demo. Yeah, evaluating that, it's really cool. Of course, I think before you had to use pre-script node processor.
Script processor node.
Script processor node, yeah, and you had to do the timing yourself and all of that. So I think this is like a huge upgrade from that. One of the problems, of course, is that it's lacking broad support. I mean, Firefox nightly also has it now, but yeah, in essence, I mean, there's still a lack of support. There is, luckily though, there is polyfills, so you can make it work on any kind of browser, and I think the WASM synth even, I mean, should work on, but I tested on, I think, Safari and Mozilla on Firefox, and it should work. Conclusion. Yeah, I don't know, for me this was a really rewarding project because it taught me something that I've never done before, and it turns out it works and you can actually learn this stuff by yourself, and so I'm really pleased with the result. I didn't fully learn C++ of course, but I got a glimpse into what it's like, so that was super fun for me too. And of course also, I mean, diving into a new field and like seeing all of this new stuff, I have some ideas too. And yeah, by the way, this slide is definitely frying my computer. So yeah, I mean, it would be, to me, it would just be super awesome if like now that, you know, we have WASM, we have the audio workload and all of these things, you know, we can have much more tools on freely available on the web that allow people to just press a bunch of buttons and there's cool noise coming out of your computer. And so, I don't know, it doesn't have to be free or Libre, but it just, I mean, that would of course be awesome, because then Richard and Linus would be happy too, and they would, you know, ask you for a friend's request. Yeah, thanks for listening, and yeah, if you have questions, let me know. And also, I'm writing a blog post. It's taking longer than expected. Who would have guessed? But that will be out in like, I don't know, 1 or 2 weeks, and will be, yeah, thanks.
Thank you. Any questions?
So I'm quite curious that you built the front end for this in React. Did you find any issues with the bridging between React and the audio workload itself, given that, you know, you've got the virtual DOM and all that stuff? How did you find that whole thing?
I didn't have any real hiccups, I would say, because because, I mean, essentially what I'm really doing is I'm listening. So, for example, for the keys that I'm pressing on my keyboard, of course, these are event listeners in JavaScript that I instantiate through React, right? And then, you know, those send it over to the worklet through the message port. So I don't think React is, like, we are not really touching even React in that sense. I think we are then touching it, of course, again, when we are lighting up the, you know, the keyboard itself. So you have like this feedback here. You see that the key, of course, is lighting up red. But I didn't have any, I didn't have any problems.
Like latency-wise or anything like that?
No, I think, no. Problems, really the problems about this whole thing was more compatibility, things that were not supported. Of course, when you Google something exotic like embedding WASM into audio worklet, nothing shows up anywhere. So these were my problems really, that I really hit my head against those. One particular example is that I think Google has this examples page of the audio worklet where they teach you how to embed WASM into the audio worklet essentially. And what they recommend, or at least the example does so, is they use the import, the import from syntax. And well, that is not widely supported, and especially it's almost nowhere supported in worklets. So I think it's not a good idea if you want to ship something today to do that. And so what I did essentially is, I mean, it's very simple. I just take this huge file that I get from mscript and I just append it in front of, I just put it in front of my worklet file. And then that's just my worklet file, and I don't use any kind of import, fancy import syntax and stuff. I just hack the thing essentially. So these were really the problems in my opinion. And of course, then I mean, I'm not so well versed with the math and stuff like that. So.
Cool. Any other questions? All right.
In your example, you basically call this WebAssembly function for each sample. Did you try somehow maybe to pass the buffer or like generate the whole buffer in WASM and then pass it somehow?
Yeah, so I mean, we can also just check this out on the repo. Essentially, it's not every sample, so wait. You can, this is the actual processing function. Can you see that? This is the processing function that WASM synth is using. And actually, the audio worklet itself, it kind of defines the frame size or the buffer size that you are submitting to the graphics card. So you can get it by checking the length of the output object that you get. And for Chrome, I think it's, I'm not sure, but I think it's always 128 samples. I think it's different for other browsers. So I think Mozilla, Safari has, I think 4096, but that's the way you do it. Yeah, and so you're not, it's not every sample.
Any other question?
Thanks for the talk. That was super interesting. This notion of doing the reverse engineering and the autodidactic approach, I think, is super commendable and really neat. So thank you. I had a question about it's not in one of the question mark segments, but the reverse engineering of like the UI and then the different waveforms. Can you talk a little bit about how you did that?
Yeah. Yeah, that's, I can do another talk about that probably. So I just did it by playing around with Ableton. So I think particularly for for this graph, it's written as an SVG. So all of this is like an interactive SVG. And then I think the interesting part about it is if you look at the values on the left here, because not only do they change, of course, when I drag this and stuff like that, but they are also how do I say, like they are based on functions. So like this is an exponential function. I think the attack, look, I mean, it's going from 0.3 milliseconds, then it's 1 millisecond, then it's, you know, all of a sudden we're like half a second, and now we're at 18 seconds. Yeah. So, yeah, that was another journey basically that I had to do. Took me a while, and of course it doesn't work fully. I think the operator, you know, you can drag the attack, for example, down, and then I think the attack becomes linear and not logarithmic. And there's a bunch of other things that I didn't do. Yeah, I just took a look and I mapped my function close to theirs by trial and error. And then for the different square waves, there I think I used a bit more. I reversed it. I mean, I looked up. I mean, you don't have to look up the sine wave, but I think you know, the square and the saw wave and the triangle wave, they were not immediately apparent to me, so I looked them up. They were most people, they define, you know, the digital ones. I think you call, I don't know if you call it digital, but I think Ableton does so. And you know, these are the clean ones. So the ones where you go from really from 1 to -1. These are the digitals. But then there is, you know, the approximated ones where you add, let's say, yeah, here it's 3 sine waves in a certain interval, with a certain distance together. And yeah, for this I checked on Wikipedia, and then also I use this tool. It's called Spectrum. So that I use this tool here. I mean, it's giving you a spectrum, and I pressed on Ableton, and then I pressed on my page, and then, you know, you see the, oops, yeah, I found that actually very useful, thanks. So I just saw, you know, that it's very similar. I think it's correct for, I think it's incorrect for 1 or 2, but apart from that, I think it should be fine. Yeah, and by the way, I mean, all of these, like the knobs, so notice how these knobs, you don't have to like go in a circle, which I also found really annoying, so you just go up and down, and like all the buttons and UI elements, they are available as React components, you can just grab them and do whatever you want.
That's awesome. Any other questions, perhaps? Well, if not, you can always do it later, so thank you again, Tim, very much.
Thank you.